Hello, I'm Megar Çiftçi. I'm a second year physics student at Bilkent University. In this video, I'm going to explain the Phys-211 project of our project group. The main objective of this experiment was to explain the formation of rainbows, in particular the primary rainbow, using reflection, refraction, and dispersion. Rainbows are beautiful natural phenomena that occupy the minds of big thinkers and scientists who tried to understand them throughout the history. This experiment was mainly inspired by Descartes' experiment that was conducted in 1600s, where he found the deviation angle for different colors using a spherical glass. In this experiment, our aim was to successfully measure the deviation angle for red and green lasers and explain the effect of dispersion in the context of rainbows. Firstly, let's talk about the theoretical background of our experiment. Let's start with Snell's law. By the Snell's law, the path that a light ray follows in a raindrop can be shown knowing the initial angles and refractive indices of mediums. Also, Cauchy's law gives the empirical relationship between the wavelength of a light and its corresponding refractive index in a specific medium. It was found that approximately refractive index was inversely proportional to the square of the wavelength. Combining Snell's law and Cauchy's law, it can be inferred that when a white light that contains all the colors enter a raindrop, each color will disperse differently. For the next part of the theory, we found the deviation angles. For the next part of the theory, we found the deviation angles for red and green lasers for the flask that we were using. Calculations were made for two different scenarios. In one of them, the glass was not taken into account, whereas for the other, it was. The details of the calculations are in the final report. For the one where the effect of the glass was also included, the deviation angle for red and green lasers were found 42.14 degrees and 41.55 degrees respectively, which were reasonable. The equipments used are, as you can see, we carried out this experiment several times. In the first try, the setup was simple. The boiling flask was filled with water. It was put on a jar, which was positioned on the ground. The red laser was affixed to the tripod with the help of a glue material. Then the tripod was positioned on a stair so that light could be sent from a certain height. In the second attempt, the same setup was used. The angles alpha 1 and alpha 2 were measured, and by summation we found the deviation angle, which ended up being 23.45 degrees, whereas the expected result was 42.14 degrees for the green laser. And that was caused by a misunderstanding that I will mention later. In the third try, we were able to collect data. The setup remained similar, except now a rope was used instead of a jar to allow the rays to leave from the bottom of the flask without being disrupted by the glass. For each of the lasers, the deviation angle was measured from 3 different positions. The results were like this. The error percentages were way higher than we expected, which was 19.78% for green laser and 15.09% for red laser on average. The reason was the initial angles that the laser beams were sent with being chosen randomly. This was one of the biggest mistakes we made. Another major mistake that we made was that we underestimated the possible effects of the misalignment of the lasers. What we did was that we marked a point on the flask and sent each of the lasers to that point separately. So their positions are clearly a little different. And when the light beams refract and disperse, that small difference would no longer be trivial for us. In the last 2 attempts, to solve the misalignment problem, 2 lasers were sent to a piece of glass which made 45 degrees with each of the laser beams. The component of the red laser that passed the glass without changing its direction and the component of the green laser that was reflected from the glass were the ones that were intended to be aligned. The alignment process required high precision, and it took us a quite long time to get it done. And for each time we ruined the setup, we had to do all that all over again, and it was hard. And after that, the deviation angle was measured by taking several photos and inspecting them. The arctangent function was used while finding the deviation angle. But unfortunately, the quality of the photos were not optimal, so we chose several points and determined the minimum and maximum deviation angle. And we took the average of them to get maybe a better result, which are now on the screen. And this time the error percentages were 2.59% for green laser and 0.4% for red laser. And the difference in error percentages could be caused by either misalignments or, as we were finding the angle from the photo, we might have made some mistakes.